Hi teachers, this is the instructional guide for Primary 3, Term 2, Week 2. For this week, there are 3 booklets. First one is on multiplication. Our first 2 are on multiplication with renaming. And then the third one is on the quotient and remainder, right? So let's start with the first one. I would say let's just skip the first part and move straight into demonstrating, right, how the questions are done for them, because they've really done booklet 1 early on. So let's just proceed to page 6 and then question F there, right? So you might want to, on the board, right, can demonstrate them, or you can use our whiteboard as well. So 460, I think the way that we need to explain this is what is 462 times 8. So work them through the steps, right? The way that we do this is 2 ones times 8, right? Remember to use the word 2 ones, 6 ones, and 4 tens. So 2 ones times 8 equals 16 ones. So you put the 6 ones here, and then you put a 1 10 there, and then 6 tens times 8 tens equals to 48 tens. 48 tens plus this 1 10, right? They got to be able to explain it, right? Or rather, you need to explain that way so they understand that this is about renaming. So 48 tens plus 1 10 equals 49 tens. And the 40 tens becomes 400 here, right? You put a 400 here. So 400 times 800 equals to 3200. Okay, 3200s plus 4 equals to 3600, all right? And so they write answer like that. Now, you might want to draw this out as you explain, right, to them, or before you explain, right, so that they know that you are doing it by place value. And this is thousands. Okay, so quite straightforward. And then I would skip all the way to, let's see, page 11. Get them to do it on their own. So this is the opportunity for you to go around and make sure that they're able to do this on their own, right, independently and so on, okay? If any students need more practice, you can ask them to do a few more. And then let's move on to question, page 13, H, which would involve thousands, right, renaming into thousands. Now, you notice some students may do it slower than the rest. As long as they understand, right, that they are renaming, right, that is fine, right? Because you might not want to wait for one student who takes a longer time doing multiplication because he or she is unfamiliar, right, with multiplication. So this may take some time. Okay. In any case, right, for students who are not able to remember multiplication, right? So for example, 6 times 6, if they cannot remember, right, quickly get them to write down 6, 12, right? They can always use this method, 18, okay, 24, and then 32, right, 36, right, and so on. So this is times 1, times 2, times 3, times 4, times 5, times 6. Okay, if they cannot remember, get them to do this method. Otherwise, they'll take a very long time working on it. Okay. And then let's see, we will skip all the way to do one more question here, which will require them to refresh the idea of what product is. And of course, they got to write the algorithm down. Okay, so that should take quite a short time to do it. And then I would say go through one question with them here. Okay, so for this, they should cross out, use the digits given below to form the smallest 3-digit number. So smallest 3-digit number would be 1, right? Next smallest 3, next smallest 5, right? Get them to cross out so it's easier for them. So they know it's 1, 3, 5, and then pick the greater digit of the remaining 2 numbers, which is 7, right? Multiply 7. So as long as they understand this, that's fine. Okay. And then that's it for this booklet. Let's move on to the next one. Okay, for the second booklet, it is actually more practices. So I'm going to skip some of these practices and go to the later ones. All right. So questions like this would get them to be able to so-called understand why certain ways are wrong. So you can go through this quickly with them. Or if you think that your class is has really grasped concept, just get them to do this. All right. So the instruction is whether Jane's answer is right for this, whether Jane's answer is right for that one over here. And if it is not correct, they got to do the working. Okay, they got to show. Right? You should be able to briefly explain, which you can get them to describe verbally. Okay, and let's see, then we do one word problem here. 8 times 20, there were 24 oranges in the box. How many oranges are there? So they have the right equation, and then they have to write the statement. If they don't write in full sentences, at least they got the right 992 oranges. Okay, put an answer there so that we know that that's the answer that they're looking for. Right, answer. The minimum requirement, right? They have to. So I will not accept 192. Minimum requirement, get them to write 192 oranges. It's very difficult to write on the using my mouse, so I will just not do that. Okay, then we try a question like this. Okay, this may be a bit challenging for some students, right? So they have to guess. So it's almost like a trial and error thing. So 9 ones times 5 equals to 45 ones, right? 45 ones. That means that they should put a 4 here. So now they got the thing, right? 5 times which digit, single digit, will end up with 4 in the tens place, right? So 5 times 0 equals to 0. 0 plus 0 tens plus 4 tens equals 4 tens. So possible to have 0, right? So they can think about it as, what if this is 0, right? And then, okay, so then let's move on. So what about 4 times 5? 4 times 5, 400 times 500 equals to 20 hundreds. But then there is a 100 here. So that means that's not enough, right? There's actually 1 here. So what should it be then? It means that there is some regrouping involved early on at this stage, or renaming involved. So let's try it out. So if 0 is not, they can try 1. 1 times 5 equals 1 tenths of 5 tenths, right? Equals to 5 tenths. 5 tenths plus 4 equals 9 tenths. Doesn't make sense. What about it is 2? 2 tenths times 5 equals to 20 tenths, right? Sorry, 2 tenths times 5 tenths equals to sorry, what am I saying? 2 tenths times 5. Oh, wait a minute. 2 tenths times 5 equals to equals 10 tenths, sorry. Right? So 10 tenths plus 14, right? 14 tenths. So you put a 4 tenths here and then 100 here. And then that makes sense. So that means star equals to 2. Okay? Work this out with them. And then I think that's it about this. The rest, I think they are quite familiar with what needs to be done. I will assign some of those as homework. Then let's move on to the last booklet, which is a bit different from what they've been learning so far. So I would say perhaps about more than 1/3 of the time, or perhaps half of the lesson, right, should be put on this, right? Half an hour should be put on this. The rest are quite easy, right? So I'll leave it to you. So anyway, the idea here is to understand quotient and remainder, right? So get them to understand this. If there are 16 cookies and they put it equally into 3 plates, right? So that each plate would have equal number of cookies, right? And then the question, how many cookies are there on each plate and how many cookies are left over? The leftover is the one that cannot be placed on the cookie, right? Because that will not be equal. Explain to them that way. So that will be 16 divided by 3, isn't it? Right? 16 divided by 3 plates. But 16 cannot be divided by 3, so they have to try. That means if they put 1 by 1 here, right, you will find that you can only put 5 cookies on 1 plate, right? And this add up will be 15. But there are 16 cookies, that means there's 1 left over, right? 16 minus 5 equals 1. Okay, so what does this mean? It means 5 cookies on each plate. The 5 is quotient, right? Which is equally, right? The equal number of items on in each group, and then remainder is the one that cannot fit in, right? So that's what remainder means. Okay, let's do another one. 31 divided by 7. Now that if let's say without the images, how do they do it? So first of all, they got to think about 31 divided by 7. We can do it that way. 31 divided by 7, okay, equals. So they've learned this before, multiplication fact family. 7 times which number will be equals to 31? Now there isn't. So what they look for is 7 times a particular number that would get a total that is, or product that is nearest to 31 but smaller, right? above cannot. So they can actually, if their times table are good, right, they can quickly do, okay, 10 times 3, right, or 10, 7 times 3 or 7 times 2, right, and then they realize that, oh no, 4 times 7, 28, that's the closest, because 5 times 7 is 35, is really too much. So if they are not sure, as what I mentioned just now, get them listed out, 7, 14, 21, 28, 35, right? So the number must be smaller, right? Closest to 31, but smaller, right? The 31, so it'll be 28. So that means 7 times 4 will be 28, and then you take 31 minus, you take 31 minus 4, that will give you a remainder of 3. All right. Okay, so 4 is the quotient, 3 is the remainder. All right, so this will take some time. Get them to do the guided practice, right? If you think that you need to demonstrate a few more questions, you can do it. But I think this first question is important. Not all the time would that be remainder, right? You can reassure them, right? They may get confused. They are looking up for remainders. But if, let's say, the number can be shared equally among 5 here, right? 35 can be shared equally among 5, then there's no remainder, right? There's no remainder here. Okay, so get them do this. I think the first question would be harder than the rest. So make sure that they complete all the questions under guided practice. Guide them along, especially all these steps here, right? Which just now I've explained, they may not be familiar. So make sure that you take them through, right? Might want to demonstrate one more time, right? How to do this, if you like. And then that's it, right? For the guided practice. Then I would say skip some of the questions here, and I would like you to move all the way to page 11. Okay, this is one level up, right? So they can notice when you divide an odd number by 2, the remainder will be 1, right? So tell them, right? Odd number divided by 2, this is the knowledge here. And you divide by even number by 2, there'll be no remainder. You can demonstrate a few numbers for them, right? Say, for example, 5 divided by 2, right? It's odd. 7, right? Divided by 2, there will always be remainder 1. And then when it's even number, 6, 8, there's no remainder, right? Because it is just, we cannot use factors yet or multiples yet because they have not learned it. So we just have to say that it can be divided equally, right? That's why there's no remainder. Then question 7. Okay, so they have to pick which numbers will give a remainder of 1. So remember what they learned here, right? Remainder of 1 divided by 2. Okay, it is all the odd numbers. And then just for even numbers. Right, here you can accept a few numbers here, but typically the answer would have to, okay, include 0, 2, or 5. So they need to know that if they can be divided by 2 easily, then it by 2 equally, then and there's no remainder, then it must be 0 or 2, right? Because these are even number. Okay, get them to do a few more practice. A, B, C, if there's still time, right? Make sure that they know how to do this. Because I'll be assigning homework based on that. They can do it on their own at home. And then question 9. Okay, the equation. And now, because it's 2-part, they got to answer it correctly. Make sure that they put A, and then they put B there, and then answer the question accordingly, right? So teach this. That's a minimum requirement. If you have some more time, you can actually work on this with them as well. Okay, and that's it for week 2. Sorry, yeah, for this week's lesson for P3. Thank you.